Hello guys, welcome back. I hope whatever we have discussed yesterday it is clear to you, and in the previous class I gave you a few questions actually. Okay, so this was yesterday's homework if I'm not wrong. Okay, and usually I remember whatever I have given. Okay, so the question was that you are supposed to identify what was the class of all these IP addresses, right? So again, if you have done it, that is well and good. If not, we are obviously going to discuss this thing, right? So if you want to identify the class of IP address, you are just bothered about what is there in the first octet, okay, and compare that thing with the range, and your job is done. Okay, so if it is 192, it would be most probably so. What I'll do is, rather than just trying to memorize everything, okay, there are different classes. That is class A, right? Then we have class B, and we have class C, class D, and class E. Class A is 0 to 127, class B is 1 to 8 to 191, class C is 192 to 224. Sorry, it is 223, I guess. Yeah, then it is 224 to 239, and the next one is 239 240 to 255. If I have committed any mistake, just let me know, and I'll be correcting it. Okay, for the time being, I hope you have understood my motive for writing the class range over here. Okay, so 192 falls in which class? It falls in class C category. 128, it falls in class B type category, and 221, it again falls in class C type category. Okay, done. So this was one question. Then the second part was obviously to elaborate these whole IP addresses in the form of bits, that is 10 10 10, so on and so forth. Okay, that this is an example that I am trying to tell you. And the next one was everything about who controls everything, or who designs these protocols, or who all these things. Okay, so that is again analysis based question. I am not going to give answer this soon. You are supposed to research it. If you are not going to research it, then there is no point of me telling everything that why is it so. All right, so enough with the homework discussion. Let's get going, and let's continue. Okay, till previous class we had talked about only one thing, that is classes of IPv4 addresses. Okay, actually this IPv4 addressing can be done in static and dynamic manner. Again, this is the topic of discussion later on, but for the timing we are done with this part. Okay, now there is something else to it. Okay, so let me change the color of my pen. Yeah, there is something else to an IP address. Actually IPv4, okay, it is of 32 bits. We already know it, and these 32 bits are divided in two parts. Okay, they are divided in two parts. One part is for network, another part is for host. Okay, one part is network, another part is host. What I mean to say is, host is nothing but the device that we are using. Okay, and network is nothing but the we can say it is the network to which we are connected. Okay, what I mean to say is that how would you identify a device in a particular network? Okay, how would you do so? By the help of an IP address, can you identify to which network that device belongs to? Okay, yes, we can do so. We can do so with the help of these network bits. Okay, these are network bits and these are host bits. Okay, so what is network? Basically, if I'll in layman terms, okay, let's say there are three different regions, 1, 2 and 3. Okay, let's say this is region number 0, region number 1 and region number 2. In all these three regions we can have, let's say, 128 computers. Okay, so 128 devices are going to be there. So I'll write 128 over here, 128 over here, 128 over here. Now the numbering on these devices within each region would start from 0 and it would end at 1 to 7. Similarly over here it would start from 0, it would be 1 to 7, it would be 0 and it would be 1 to 7. Can you notice one thing, that the numbering of each device or the numbering of devices in all the regions is from 0 to 1 to 7, but the only thing that is isolating them from each other is the region, right? If I talk about region 0 and PC 28, it means I am supposed to locate PC 28 over here, that's it. If I'll tell you region 1 and PC 100, it means I am supposed to talk about this. So over here in this context, this region 1, region 0 and region 2, that is helping me to identify the overall presence of a device, okay, is nothing but network. Okay, this is one network, this is another network and this is another network. Similarly, all the number devices, they are nothing but host bits. Okay, host bits. Okay, so the host bits can be same, but the network bits cannot be same, one thing. Alright, another example that I will give you is, if we'll get call from India, so it would be most probably from +91 number from this extension followed by some number. Okay, so can I say +91 is the network of India? But if I'll do +92, it is not of India, it is for someone else. If I'll do +100, it can be for someone else, it can be for a different network, right? I hope you are getting it. Okay, this thing is quite basic, but still it is only related to logics. Okay, so to sum up, what I meant to say is an IPv4 address was divided in two parts, that is network ID and host ID. Okay, I'll write it like this. Okay, so let me draw the structure once again like this. So there were 4 octets, this, and each of these octets were 8 bits. Okay, so if I'll talk about class A, for class A, okay, I'll change the color. Okay, for class A, first 8 bits belong to network, okay, or network ID, and rest 24 bits belong to host ID. What I mean to say is, network ID is of 8 bits, host ID is of 24 bits. Got it? It means if network ID is of 8 bits, total number of networks that can be designed using class A would be 2 raised to power 8, as simple as that. If there are 8 bits, 1 2 3 4 5 6 7 8, so you can have either 1 or 0. So there are 2 possibilities in each bit space, so that is nothing but 2 multiplied by 2 multiplied by 2 till 8 times, that is nothing but 2 raised to power 8. The result is 256. Okay, so total number of networks that can be designed from class A are 256, but total number of hosts within total number of hosts within each network would be what? 2 raised to power 24, which is a very huge number. Okay, so one network can have these many hosts. Okay, so can I have class A type address in my home? No, I should not, because the number of hosts are 2 raised to power 24 and I am never going to use these many IP address, these many hosts within a home. So that's why we cannot use class A. We can only use class A in such environments wherein wherein the number of hosts within a particular network is very large or huge. Okay, then if I'll move on. Okay, now I'll change the color once again and I'll draw the IPv4 structure over here once again, 1 2 3 and 4. Okay, so again I'll talk about class B. Okay, now within class B I'll use a different color. Over here your network IDs were first 2 octets. Due to whatever reason they came up with this idea, and host ID was also last 2 octets. Okay, if you'll notice, network ID is of 16 bits and host ID is also of 16 bits. Simple. Okay, and they introduced this type because we could not use, or we were not having that many networks for class A. So over here the number of networks for class B would be 2 raised to power 16 and the number of hosts within a particular network would be 2 raised to power 16 as well. Okay, so the number of hosts within a particular network has been decreased significantly, but still we are capable enough and we are not going to have that many devices within every single network. That's why we do not have class B as also. Okay, but number of networks have been increased. Okay, then they came up with something that is known as what happens for class C. Again 1 octet, 2nd octet, 3rd octet and 4th octet. Okay, so we have class C. Within class C I'll do one thing. First 3 octets belong to network ID and the last octet only belongs to host ID, which means what? That your network ID is of 24 bits and your host ID is of 8 bits, which means total number of networks that can be designed would be 2 raised to power 24, whereas total number of hosts that can be designed would be 2 raised to power 8 per network. So I'll write per network over here and I'll write per network over here, so that you guys are not confused and you are not going to blame me at the end. Okay, now if you'll notice this number is nothing but 256. That is 256 hosts per network, so it is bearable. We can have these many hosts within a particular network, and now the number of networks have been increased significantly. So that's why majority of the times we have a class C type of address. Okay, we have a class C type of address. Furthermore, if you are studying everything in advance, you will notice that we are not going to use all these. So we subtract something like this. We subtract 2 from each value in host. Okay, I'll tell you why. Okay, I'll tell you in the later classes, obviously. Okay, not right now. It is too much for you guys to digest. Okay, now you will have a question. Sir, what about network IDs and host IDs for class D and E? If you remember, I had told you yesterday, or we had discussed about this thing yesterday, that these classes or class D is used specifically for multicasting, Yes, correct. Okay, correct guys, correct Rohit, everything correct. Okay, and class E used for, it is used for what purpose? Okay, it is used for research and development or military purposes and all. So whatever there is, you can study the case study of these classes as well. So there was no division of network IDs as well as host IDs for class D and E. As easy as that. Okay, so if we are clear with this thing, we'll proceed on in the next video. Okay, we'll proceed on in the next video only. Okay, by tomorrow your homework is find out the IP address in your lab PC, right? You guys are having well equipped labs, right? I know this. Yeah, I've been to your classrooms, so yeah, they are great, well equipped. So you are supposed to tell me the IP addresses of those lab PCs. Okay, so am I supposed to go through properties and all? No, you are supposed to use command. Okay, use commands to find out IP address. Okay, so once you find out the IP address of your PC or lab PC, tell me the class of that IP address. One thing, tell me the network IDs that would be there. Okay, and tell me how many host IDs that would be there. Furthermore, tell me how many networks can be designed, number of networks using that class, and how many hosts or number of hosts per network. Okay, this is your only homework. Okay, at the moment we are not having those many questions, so that's why I'm not giving you that many questions. But yeah, you are supposed to go through this. If you are doing this practice over and over again, then it would be very easy, and it would be fairly easy for you guys to interpret as well as comprehend whatever is being discussed during the class. Alright, so I hope you have understood everything. If you have any doubt, just highlight the question or highlight the topic, and I'll take your topic in the doubt session, most probably by next weekend class. Alright, okay, so thank you so much guys. It's been pleasure teaching you. Bye bye, take care, have a nice day.